Hello, and a warm welcome to this webinar, Achieving CE 2.0 Network Integrity, a solid foundation to enable the third network. My name is Madan Panchaksharam, the moderator for today's session. To give an overview of this webinar, Carrier Ethernet 2.0 since 2012 has been the technology of choice for delivering standard, reliable, and manageable business services. Service providers striving to achieve CE 2.0 network integrity require state-of-art testing solution, allowing them to validate interoperability during service design, verify compliance to CE 2.0, and detect potential performance issues during service activation, and ultimately provide vendor-neutral fault management tools and performance monitoring portals during the entire service lifecycle. Most recently, and building upon the strengths of CE 2.0 and the agility of Internet, telecom networks are evolving to enable more flexible, dynamic, and on-demand services, giving rise to a whole new set of network testing requirements. In line with this evolution, MEF has announced the third network initiative to enable agile, assured, and orchestrated services between physical and virtual service endpoints using existing networks as well as NFV and SDN. In this webinar, Verix will present innovative approaches and methodologies in ensuring CE 2.0 integrity across various service lifecycle stages such as service design, service activation, monitoring, and troubleshooting. And finally, talk about how these approaches would simplify and standardize the evolution towards the agile, assured, and orchestrated the third network. The speaker for today's session is Isabel Morenci. Isabel is the Vice President of Engineering at Verix. In her previous assignment, she was the Chief Academic Officer at the Carrier Ethernet Academy, a MEF accredited training provider specialized in MEF CECP training. Isabel also worked at Iometrics as the Vice President of Engineering and Standards and served as the editor of MEF CE 1.0 and CE 2.0 test plans used for MEF equipment vendor and service provider certification programs. Isabel began her career at Teleglobe, later acquired by Tata Communications. She has received Outstanding Contributor Awards at MEF, Broadband Forum, and IEEE, and has contributed on a variety of technical specifications. Today, we are also happy to have a special guest, Ms. Casey Jones, Manager Tier 3 Support at Integra Telecom, and Rahanan Ferris, Technical Support Engineer, again from Integra Telecom. They will briefly talk about their experience in aligning their testing with CE 2.0 definitions. This webinar will have a poll question during the course of the session and finally a Q&A. I would allow you 30 seconds to respond to the poll question. And feel free to type in your questions during the course of the webinar and we'll respond to those queries during the Q&A. Before we go further, let me briefly introduce Verix. Verix is a provider of communication test and measurement solutions. Over the last 12 years, Verix has provided automated test solutions for various segments in the industry, including Carrier Ethernet, data center, cloud, and SDN. Many of Verix customers also utilize our consulting and professional services for testing network equipment and for deployment of their networks. Verix recently has been awarded Frost & Sullivan 2014 Global Award for Customer Value Leadership in Carrier Ethernet Testing. And Verix also has been named by Gartner as Global Cool Vendor in Communication Service Provider Infrastructure and Cool Vendor Asia Pacific across industry categories. For more information, please visit our website or contact us. I would now have Isabel take over and get started with the presentation.
Hello everyone. Let's get this session going by looking at a new approach to optimize CE2.0 service design. To do so, we'll dissect the MEF abstract method utilized to create carrier Ethernet services definitions and see how the same method can be applied to design carrier Ethernet services based on specific customer requirements. Carrier Ethernet services definitions are comprised of three different parts: a service type, service attributes, and attributes parameters. There are four different types of services: E-line, E-LAN, E3, and E-access, that are mainly differentiated by their topologies and external interfaces. The topology and external interfaces are important attributes of carrier Ethernet services. Other attributes are, for example, the CE VLAN ID VC map, the bandwidth profile, or the performance metrics. The parameters are the values that are directly related to specific attributes, like the bandwidth profile committed information rate, or the maximum number of CE VLAN IDs per OVC. Based on different combination sets of service attributes and parameters, the MEF has defined 8 carrier Ethernet services: EPL, EVPL, EPLAN, EVPLAN, EP3, EVP3, Access EPL, and Access EVPL. Now, let's look at how this step-by-step method can be applied to design CE2.0 services based on specific customer requirements. Here we have an example where the customer is a service provider that needs to interconnect 3 base stations to a controller site. The service provider requirements are the following: the equipment to be deployed at the base stations only supports point-to-point services. The service provider is also adamant to use a single port at the controller site to interconnect the 3 point-to-point services. Therefore, multiplexing attribute needs to be enabled at the controller site. And he is also asking for high-quality performance with very low latency and frame loss. This means that the configuration of a committed bandwidth profile will be required at all the user network interfaces. Consequently, by translating the service provider requirements into attributes and parameters, the mobile operator can design the appropriate CE2.0 services, which turn out to be 3 EVPL services. Once the service and its attributes and parameters are determined in theory, the next step is to simulate the service implementation in a lab environment and verify the compliance of the design. The compliance assessment requires the verification of each attribute configured in the service independently, a task that can be very time-consuming if the testing tools available are not fit for the purpose. One of the most important functional attributes of EVPL services is multiplexing. In our mobile backhaul example here, multiplexing is happening at the controller site, where the 3 EVPL services terminate on a single unit. Verifying multiplexing also implies the verification of CE VLAN ID preservation attribute end-to-end. And since multiple services terminate on the same interface, it's important to verify that only the specific CE VLAN IDs mapped to each service are admitted to the network and that no other CE VLAN IDs mapped at the same UNI are leaking from one EVC to another. Now that we've talked about functional attributes verification, let's look at the traffic management attributes and parameters. Mobile backhaul requires performance assurance. Therefore, bandwidth profiles need to be configured and verified for each service, with committed parameters, CIR and CBS, greater than 0 to enable service assurance. It's also imperative to benchmark the service performance for each class of service in a lab environment before the deployment in the field. Possessing testing tools allowing the verification of each and every CE 2.0 service attributes and parameters in an automated way can greatly cut down in design time and troubleshooting and improve time to market. Here's our second example of service design. A real estate company needs to interconnect its headquarters to 3 remote sites so that all the employees can have access to the systems installed at the headquarters and also have access to the internet. The real estate company's requirements are the following: interconnecting all sites as if they would be on a single LAN and provide internet access to all the employees. This will require a multi-point to multi-point service as well as a point-to-point service to an ISP. The company's IT department also demands access to all CE VLAN IDs so that they can manage their own VLANs and applications and have spanning tree running seamlessly between all 4 sites. In terms of performance, they believe that a best effort service will justly suit their requirements. Consequently, by translating the customer requirements into service attributes and parameters, the service provider can design the appropriate CE 2.0 services, which turn out to be 2 private services, one EP-LAN and one EPL service. Now, let's look at the verification of point-to-point and multi-point private services and at what it involves. First, the implementation of multi-point services require a transport protocol that supports MAC learning, such as VPLS or provider bridging. Therefore, it's important to initially verify the interoperability of all the equipment operating at the external interfaces in a lab environment. Secondly, private services such as EP-LAN and EPL require the support of all-to-one bundling, meaning that all 4095 CVLANs must be allowed into each service and that all combination of VLAN IDs and PCP bits must be preserved end-to-end. The verification of all-to-one bundling could be a very lengthy process, especially if troubleshooting is involved. The utilization of a fully automated test suite with assisted troubleshooting can cut down threefold in the trouble resolution efforts. Finally, the Layer 2 control protocol handling verification, tunneling spanning tree BPDUs in this specific case, can also be quite challenging if it has to be executed manually. Again, possessing the right testing tool definitely allows service providers to improve their service time to market. As seen in these 2 examples, and most of the real-world deployments involving carrier Ethernet services, making use of a forward-looking, fully automated testing tool accelerates and optimizes the service design process by allowing the verification of equipment interoperability, the compliance of service attributes and parameters across multiple devices and transport technologies, the service's configurations and scalability under different traffic conditions, the benchmarking of service performance, and a rapid verification of custom designs with a fully automated test suite. Now, let's move one step ahead in the service lifecycle and look at cutting-edge test methodologies for service activation testing. Like the proverbial tip of the iceberg, turning up carrier Ethernet services using a well-known service activation methodology such as the RFC 2544 or the ITUT recommendation Y1564, focusing mainly on service performance, can lead service providers to overlook a number of functional and traffic management problems that would lie undetected until subscribers would start using their services. The verification of functional and traffic management service attributes such as CE VLAN ID preservation, CE VLAN cause preservation, EVC mapping and leakage, Layer 2 control protocol and service OEM handling, MAC learning, and bandwidth profile parameters during each service activation is an important step in achieving CE 2.0 network integrity. Here's an example where SAMTEST is deployed in a service provider network and utilized for service activation testing across multiple operator domains. The SAMTEST system is composed of a centralized controller and test probes that can be deployed in key network locations. Service activation testing can be performed in a probe-to-probe configuration, as depicted on this diagram from the local UNI to the ENNI, or in a probe-to-NID configuration, making use of a smart loopback or a Y1731 loopback at the remote UNI. SAMTEST architecture allows service providers to have the flexibility to choose the appropriate topology based on the attributes of the services under test. SAMTEST fully automated test suites allow for a comprehensive verification of each carrier Ethernet service being turned up by going a step further than the RFC 2544 and Y1564 and adding the verification of all CE 2.0 functional attributes using the CE 2.0 bandwidth profile test methodology and reporting on all CE 2.0 performance metrics. Now that we've reviewed the enablers of service design and service activation testing, we'll move on and explore some of the main challenges faced by service providers and how the use of testing tools with assisted troubleshooting capabilities and automatic diagnostics can improve their operations efficiency, reduce testing time, and minimize the potential for human errors. The main challenges related to the operation of carrier Ethernet networks can be classified into three categories. The VLAN-specific attributes, comprising mapping, leakage, and preservation. The bandwidth profile parameters configuration and operation. And the control protocol handling, including Layer 2 control protocols and service OEM fault management service transparency. Troubleshooting the complex issues that arise from misconfigurations of VLANs, bandwidth profiles, or control protocols can be very time-consuming, lead to service non-availability, and ultimately to SLA violations. Fortunately, innovative and intelligent testing tools with assisted troubleshooting and automatic diagnostic capabilities are now available for service providers determined to improve operations efficiency and prevent SLA violations. To illustrate these challenges, we'll look at three cases. The first one is about VLAN attributes, configuration, and troubleshooting. In this case, two EVPL services multiplexed at the local UNI are deployed across multiple operator networks via a standard ENNI. In such complex multi-operator deployments, the potential for VLAN misconfigurations is quite high, so the verification of CE VLAN ID EVC mapping at all UNIs part of the service is a good practice. In addition, the verification of the S-VLAN ID mapping at the ENNI to allow traffic to be exchanged from one network operator to the other seamlessly is also a proactive way of ensuring faultless service delivery to the customer. and particularly in deployments that involve VLAN-based services with multiplexing, VLAN leaking verification during service activation from one service to the other is essential. In this particular case, the use of a single SAMTEST probe placed at the ENNI with loopbacks activated in the devices located at the local and remote UNIs enables a comprehensive verification and troubleshooting of all VLAN attributes and parameters of the services. Now, let's look at a little deeper into the role of the bandwidth profile as a service attribute. The bandwidth profile is the actual function that enables service assurance. In the carrier Ethernet world, the bandwidth profile follows the two-rate, three-color algorithm principles, where the role of its committed and excess parameters are to police and declare frames green, yellow, or red at the ingress of the service. The green frames are the ones that must be delivered as per the performance objectives specified in the SLA, whereas the yellow ones may be delivered but without performance assurance. Red frames must be discarded right at the ingress interface. Due to the dynamic nature of the bandwidth profile algorithm, the verification of its parameters such as CIR, CBS, EIR, EBS must be fully automated and using the rigorous and latest MEF-defined test methodologies. And should a problem related to the bandwidth profile arise in the network, it's imperative to have automated troubleshooting and diagnostic tools to help isolate the issue in a timely manner by reporting the exact measure values instead of a simple pass or fail. Now let's conclude this section with the third most important challenge when deploying CE 2.0 compliant services, the control protocols handling. Each CE 2.0 service has its own specific requirements for handling L2CPs. The compliance to CE 2.0 requires the verification of 35 stateful protocols per service, which can become a very lengthy process, highly susceptible to human error. In addition to the Layer 2 control protocols, CE 2.0 also mandates the service transparency to the continuity check, loopback, and link trace fault management protocol at the subscriber and test meg levels for a total of over 40 protocols to be verified per service during the design and service activation phases of the life cycle. Control protocols verification is another area where SAMTEST fully automated test suites greatly improves testing and troubleshooting efficiency. Now that we've discussed about various approaches to achieve CE 2.0 network integrity during service design, activation, and troubleshooting, let's hear about the experiences of our guests, Casey Jones and Rhiannon Faries from Integra Telecom, a carrier Ethernet service provider based in the United States. Over to you, Casey and Rhiannon.
Thank you, Isabel. So typically, Integra turns up around 30 e-access services a month. Within those, only 2 pass the initial testing and all the rest fail, as shown in the pie graph to the right. Before we use SAMTEST and the service would fail on the initial test, the time we spent on troubleshooting was substantial at about 95% of the time. The first column on the bar graph to the right shows the amount of hours spent a month troubleshooting the failed circuits at approximately 8 hours per service. We are working towards using SAMTEST CE 2.0 for testing and troubleshooting those services, which will decrease the amount of time spent by almost 75%, shown in the second column on the bar graph. Now, Casey will cover the troubleshooting aspects.
Thank you, Rhiannon. With SAMTEST, we've been able to dramatically reduce the amount of time spent troubleshooting. One of the most significant contributions has been the reports provided in the test results. These reports and the information from them have been very useful in the technical exchange between Integra and our partner carriers. The net result with the scripted testing environment has been a very dramatic reduction in the amount of time spent troubleshooting, both in Integra's network and with our partner providers. Thank you, Isabel. Back to you.
Thank you. So, increasing service availability is a common objective amongst the service provider community. One of the many ways that contributes to reaching this objective is the proactive detection of service degradation. The main difference between plain old Ethernet services and carrier Ethernet services is the quality of service. But is performance monitoring sufficient to assure quality of service? No. With all the new high-definition and real-time application offered on carrier Ethernet networks, it's important for service provider to be alerted when the performance thresholds are to be exceeded and receive auto-diagnostics, allowing them to take the appropriate actions and avoid the SLA violations. Proactive monitoring and detection of service degradation is an important feature of the SAMTEST platform. Its centralized architecture allows multi-operator network monitoring and troubleshooting independently of the network equipment installed in the access, aggregation, and core networks. Its real-time monitoring of all performance metrics, standards-based frame size, rates, and monitoring intervals makes SAMTEST highly interoperable with the systems already deployed in service provider networks. Ultimately, SAMTEST alarm generation when SLA thresholds are about to be exceeded, and auto-diagnostic tests for quick fault isolation makes it one of the most advanced multi-layer portal proactive monitoring system in the industry. We have now discussed various aspects of ensuring CE 2.0 network integrity. Before we move forward to discussing how this is important for the evolution towards NFV, cloud, SDN, and ultimately to the third network, let's do a quick poll with the audience. Over to you, Madame.
Thank you, Isabel. The poll question is, what is the timeline for implementation of NFV in your company's network? And the options are implementation already in process, planning to implement in next 12 months, planning to implement in next 24 months, not considered yet. Please click on one of the displayed options. So Isabel, as the audience poll is in progress, how do you think service providers are progressing with the implementation of NFV?
Madame, I'm looking forward to hearing the feedback from the audience, but I feel that NFV is really starting to see adoption by service provider. It has pretty much passed the stage of only being a hype. While service providers are in different stages of consideration, the primary challenge I see is the availability of the right testing tool to benchmark their NFV proofs of concepts. We've already seen and receiving several requests from both equipment vendors and service providers asking for tools and methodologies to benchmark their prototypes.
Thank you for providing the responses. Isabel, can you continue with your presentation?
Yes, Madame. So, to conclude our discussion, we'll be looking at the evolution of test solutions to support the third network. As most of you are probably aware, the MEF has recently introduced the third network initiative to enable services between physical and virtual service endpoints using existing networks as well as NFV and SDN. Deploying and supporting orchestrated, agile, and assured networks requires the use of test and measurement systems with the same characteristics. Centralized orchestration remains imperative with the support of OpenStack to control the deployment and provisioning of virtual machines. The static deployment of physical probes is enhanced to support the dynamic spinning of virtual probes, allowing the verification of on-demand cloud and carrier Ethernet services. And the generation of stateful traffic such as TCP, UDP, or HTTP for verifying applications like voice over IP or video on demand. When networking functions such as load balancer, firewall, or router are moved away from external devices into the network as virtual functions, it becomes a necessity to verify their impact on the end-to-end service performance. Using a combination of physical and virtual probes, service provider can measure performance and troubleshoot between physical and virtual service endpoints, accelerate fault diagnostics by measuring between segments of the network, and perform monitoring and analytics of virtual network functions. Now that we've completed the overview of some of the methodologies and recommendations to ensure CE 2.0 network integrity and how specific approaches could simplify the evolution towards a true network, I will pass the microphone to my colleague Madan for a brief Q&A session. Over to you, Madan.
Thank you, Isabel. I'm sure the audience would have found the presentation helpful. We have a few questions from the audience already, and I would request those of you who have any more questions to use the box on the top right side of your screen to type in your questions. The first question we have is, we usually perform RFC 2544 or more recently ITU 1564 for service activation testing. Can you explain how testing for CE 2.0 attributes and bandwidth profiles during service activation testing really improves the things?
So typically, when you perform RFC 2544 or Y1564, it mostly covers the performance testing aspect, and the reporting is in pass-fail format. Then, if there are failures, the bulk of the troubleshooting is left in the test engineer hands and his personal experience, so that the process can become very painful, especially when multiple operators are involved. On the other hand, if you make use of an automated test suite that addresses all the CE 2.0 requirements for service attributes, bandwidth profile, and performance, and at the completion of testing you get detailed information on which attributes or parameter went wrong, it's much faster to fix the problems and revalidate. It also makes the communications between interconnecting operators much easier when both of them can talk the same CE 2.0 language.
Sure, Isabel, thanks. The next question we have is it possible to integrate SAMTEST on existing network equipment that are already deployed in a network?
So as seen in the previous example, SAMTEST can also be deployed as virtual probes. As long as the network equipment supports spinning of virtual machines using OpenStack, then Verix vProbes can be integrated in network elements.
All right. So the last question that we'll take for today, with SAMTEST, are we always required to shift the probes to the remote access point? We're always looking to avoid the truck rolls as much as possible. What's your answer for that?
So with SAMTEST, most of the testing can be performed using loopback features at the remote interfaces. So this way you only need to deploy probes in your main interconnection sites.
Okay. Thanks, Isabel. The presentation highlighted many innovative approaches and methodologies to ensure C2.0 integrity. Using standardized approaches not only simplifies the evolution towards third network, but also in the process substantially reduces the time and effort involved in ensuring SLAs during the evolution. I would like to thank you all for taking time to join us. I trust that today's webinar would have been beneficial to you all. Verix will be demonstrating the SAMTEST solution designed to help service providers ensure C2.0 integrity and help them with the evolution to the third network at MEF Gen 14 in Washington, D.C. For those attending the Gen 14 event, please feel free to drop by the booth and we'll be happy to provide a live demonstration of SAMTEST. Others may kindly reach us at info@verixtech.com for more information. Thank you all.
Thank you, everybody.